So here we have a 120 kilogram piece of iron that's originally 250 degrees Celsius, and it's dropped into a bucket with 85 kilograms of water. If they equalize at 62 degrees Celsius, what was the original temperature of the water? Okay, so obviously since this iron is going from 250 degrees Celsius to 62 degrees Celsius, it's the hot item and it's getting colder, right? The temperature is dropping. So the water had to be colder originally than 62 degrees, so it was the cold item here. And we need to go ahead, we know this is a thermal equilibrium problem, which points us to this equation. We know the total heat in the system has not changed, but we have the hot object that is losing heat and the cold object that's gaining heat, and the total amount of heat is still the same. Alright, so we need to write our equation. 0 equals, and we'll go ahead and make a different color for the heat of the hot object, and then plus the heat of the cold object, which would be the water. Okay. So now every time we see a Q, we're going to plug in the equation for Q, right? Heat transferred during a temperature change. So 0 equals, and then we have the mass of the iron times the specific heat of iron times the change of temperature for the iron, okay, plus the mass of the water times the specific heat of water times the change in temperature for that water, which is always final minus initial, guys. Alright, so let's further elaborate. 0 equals, the mass of the iron is 120 kilograms. Alright, and then we are going to go over here and find the specific heat of iron. Alright, it is 448. And then our temperature change, final minus initial. Alright, so if they equalize at 62 degrees, the final is going to be 62 degrees. The initial it was initially 250. Alright, so notice 62 minus 250 is going to be a negative number. This guy is losing heat, which makes sense. He went from having 250 degrees Celsius to 62 degrees Celsius. Alright, now, plus the mass of the water was 85 kilograms. The specific heat of water is 4,186. And the change of temperature. Final we know to be 62, minus initial we do not know that yet. Alright, so now we can solve. Alright, 0 equals. Alright, and the calculator will tell us 120 times 448 times, and then I would go ahead and put this in parentheses, 62 minus 250. Alright, so we get a very large number. We get negative 10,106,880. Alright, and we're adding that to, alright, 85 times the specific heat of water, 4,186, and we get 355,810. And that is still being multiplied to 62 minus the initial temperature of that water. Alright, so we could go ahead and add this 10,106,880 to both sides. Alright, so this was a negative on the right side, but it will become positive on the left. And that is going to be equal to 355,810 times 62 minus our original temperature for the water. So we could go ahead and divide both sides by 355,810, and this cancels out. Okay, I'll just go back to black for the rest of this problem. Alright, so 10,106,880 divided by 355,810, and we get 28.4 degrees, or 28.4 so far. Okay, and this is equal to 62 minus our initial temperature. Alright, but we want to solve for our initial temperature, and since this is negative over here, we could go ahead and put it on the other side and say initial temperature plus 28.4 degrees is equal to 62. And then all we would have to do to solve for initial temperature would be to subtract 28.4. So our initial temperature will equal 62 minus 28.4. And we get 33.6 degrees Celsius. And we're done.